All right, we're recording. Give me a few seconds to share the screen. All right. Okay, first word, the class is now closed. I've added everybody that I was planning to add. So some of you, you know who you are if I let you in the class for doing the homework and so forth. So you should be in or not. If you're not sure if you're in the class, let me know. I gave add codes to whoever I was going to. Now, you need to process the add code right away because up to now, Canvas only puts people that are officially enrolled. So those of you that were not officially enrolled, I couldn't send you stuff through in Canvas. From now on, I'm only going to put stuff in Canvas for the most part. I will rarely send you stuff through mysmccd.edu, although check it once in a while. Okay, so what makes it easier for me is if I only put stuff on Canvas for the announcements. All right, so if I give you an add code, please process it right away. Otherwise, you won't get my announcements on Canvas. And then you might fall behind and so forth. Okay, so that's the first part. Okay, and next part about the schedule. Okay, so I'm 1.2. I'm going to finish 1.2, and I had even 1.2 scheduled for Monday, so I'm a little bit ahead. I'm probably going to sneak in a little bit of 1.3. Okay, and furthermore, I even have some buffer days here. And buffer days are not holidays. Just keep going. If I have a chance to get ahead, then I'm going to go get ahead because I might fall behind later. I might get sick. My internet might go down. Okay, last semester, and some of you were with me last semester, you know this, my internet was down for a whole week. So, you know, I obviously fell behind when that came to pass. All right. So, and then I'll lecture for a little while, and then I'll stop and give you the quiz. Okay, so I'll give you some reminders of the quiz. I know some of you took me last semester. I am doing quizzes differently this year, this semester, so you have to pay attention to this. So when it gets to be, I don't know, last 20 minutes, 25 minutes, 15 minutes, something like that, I will ask you to get your cell phones out, or if you can do a screenshot, that's fine. And I will just project on here the questions, question or questions, and you just work it out. And then I'll put you into your breakout rooms. Okay. Then on your piece of paper, put your name and the names of everybody else in your breakout room. Please, first and last name. I'm going from experience from my other classes. Okay, don't just put the first name. I need first and last name to make it easier for me to find it in my row sheet. Okay, so everybody works the problem out. Okay, so let's say you'll be in groups of 3 or 4. Okay, so everybody works it out. You put your name, put everybody else, your team member's name, work it out. Okay, once you get the answers, don't leave. Check that everybody else gets it. Okay, and then it's due by the end of class, which is 10 o'clock. So when you're finished, just click on your cell phone, or if you have a scanner, you can scan it. Okay, and then just email it to me. Okay, and you should know my email address. It's HOMM, as I mentioned before, HOMM@smccd.edu. It's on the syllabus. Okay, so email to me. I'll let you have 5 minutes for that. So what class ends at 10, I should get it by 10:05. All right, and then for me, I will look at all the quizzes. I will only grade one of them, and you're all going to get the same grade. Okay, so if you're the straight A student and you just say, I'm just going to do it and they'll leave, that's not a good idea because I may not grade yours. I might be grading somebody else's. Okay, so since you don't know which of your team members I'm going to grade, the best thing to do is you get the answers right, then you share it with everybody else. And then hopefully you get it right. So in that case, it doesn't matter which person I pick, you're all going to get it correct. Okay, cameras, it's up to you whether you want to show your cameras or not. As you can see for me, I set up my system. There's nothing back there. I have seen in other classes that, sometimes they want the camera on so they can just kind of go like this and show their answers. I suppose if you want to just do something like that or just talk about it, that's perfectly fine too. Okay, but that's totally up to you. Now, if you finish your quiz early, you may leave. You don't have to stick around until 10 o'clock. So let's say you finish 9:50, 9:55 or something like that. You can all leave, then you all, take a picture, click, email it to me, HOMM@smccd.edu, and then you're done. Okay, and then I will grade only one person. Now I'll look at all the quizzes. Okay, I'll briefly look at it, but I'm only going to grade one, and you're all going to get the same grade. Okay, now if I look at everybody's quiz and I look at it and say, hey, this looks like they're all written by the same person, right? Then, hey, what's up? Something's wrong. Okay, so I should get, if you have a group of, let's say 4, I should get 4 unique, pieces of paper. Okay, somebody's car alarm went off here, so I don't know if you guys can hear it, but there's a car alarm outside. I can barely hear myself. But yeah, I'll look at the quizzes, but I'm only going to grade one of them, and you're all going to get the same grade. Okay, so that's the way the quizzes are going to work. All right, so that's that. If you have any questions, you can put it in the chat. I don't see anything yet, but let me go ahead and lecture for a little bit now, okay? So I will get started. Okay, so I'm going to go ahead and finish problem number 6. Okay, 1 over 1 minus tangent x. So last time I left you hanging. Okay, I wrote this, but I didn't write this. Okay, now the tangent function itself, if you recall, the tangent function did a lot of this stuff. It was not defined at pi over 2, negative pi over 2, and multiples of pi after that. Okay, so here's the new thing that I added from yesterday. So minus pi over 2 plus k pi, where k is an integer. Okay, so the domain is all real numbers minus the set consisting of pi over 4 plus k pi, where k is an integer, and also minus pi over 2 plus k pi, where k is an integer. Okay, so these are the guys that makes the denominator 0. These guys over here make the tangent undefined in the first place. So in other words, if I only look at just a tangent, okay, it's undefined for those values. All right, so that was a little bit tricky. All right, so I'll go ahead and do more problems. So the assignment again was 1 through 9 all. So I want to do number 8 for you. Again, trying to do the evens. I did 2, I did 4, I did 6, and now let me do 8. Okay. So 8, what do all members of the family of linear functions f of x equals 1 plus m times x plus 3 have in common? Sketch several members of the family. Okay, so what does that mean? So here's the original problem. F of x equals 1 plus m times x plus 3. Okay, now, it would help if you think of this in terms of the point slope form. It kind of looks like the point slope form. Okay, the point slope form from algebra is y minus y1 equals m times x minus x1. Furthermore, you know that f of x is the same as y, right? So if I pretend this is y, subtract 1 on both sides. Okay, so see f of x, I made it y. I just left this other stuff alone. So f of x equals blah, blah, blah. Y equals blah, 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 blah. And then if I subtract 1, y minus 1 equals m times x plus 3. Now this looks like this. Okay? It's the point slope form. That means the point is negative 3, 1. Okay? And you just have a different slope. Okay, so what do these lines, this so-called family of lines, what do they have in common? They all pass through the point negative 3, 1. Okay, so that's the point in question here. Right, and by the way, look over here. It doesn't matter what m is. Okay. If I plug in negative 3, this is going to be 1, right? So regardless of m, take a look. What happens when you plug in negative 3? Negative 3 plus 3, 0. 0 times m is 0, plus 1 is 1. So they all pass through negative 3 and 1. So they want you to graph several members of the family, so-called. So I just put a dot, a negative 3, 1, and I just draw a whole bunch of lines that go through negative 3, 1. Right? So it's almost like I just spin around and get a different line. Okay, they all go through this point, but these all have different slopes. So I just have different n values. That's all. Okay. All right, so that's that one. Okay, so I've shown you all the evens, I believe. I showed you 2, 4, 6, 8. Leave you to try 1, 3, 5, 7, 9. Okay, and then some of these other ones, and then I'm pretty much done with the section. I might sneak in a little bit of section 3 before giving you the quiz. Okay, so 11, 13, 15, and 17. Okay, 11. Show you 11. Okay. Hopefully you saw something like this in pre-calc. I'm on page 34. Find an expression for a cubic function if f of 1 equals 6 and f of negative 1 equals f of 0 equals f of 2 equals 0. Okay, so you hopefully did something like that in pre-calc. Those of you that had me in pre-calc, we certainly did something like that. Take a look at this. Okay, f of 1 is 6, f of negative 1 equals f of 0 equals f of 2 equals 0. Okay, now all of these here, that tells me that f of x is x plus 1 times x minus 2. When f of 1 equals 0, in other words, when you plug in -1, you get 0. That tells me I'm going to have a factor of x plus 1, right? F of 0 equals 0 means there's going to be an x, or x minus 0. And then f of 2 equals 0 means x minus 2 is a factor. And then there's going to be a k in front. Okay. Now, if you're not comfortable with that, and by the way, you can pretend f of x is y. Okay. Suppose I start off with this. It doesn't matter what the k is. Well, don't let it be 0. Okay. But suppose I start off with this. So give me the zeros of the function. Then you would say, oh yeah, -1, 0, and 2, right? So we're just going backwards. Okay. If the zeros are -1, 0, and 2, then it looks like this, right? X plus 1, so that when I plug in -1, I get 0, right? X, because when you plug in 0, you get 0. And x minus 2, because when you plug in 2, you get 0. But there could be a coefficient in front, a k. How do I find a k? Now I use the fact that they told me f of 1 equals 6. That means when you plug in 1, you get 6. Okay, so I plug in a 1 for x here, here, and here. And let 6 be for y. Y is f of x. Okay, so 6 equals k times, now you plug in 1, right? 1 plus 1 times 1 times 1 minus 2. And then just solve for k. So 6 equals k times, let's see, 2 times 1 times -1, which is -2k. So 6 equals -2k, k equals -3. Right, so I found the k to be -3, so I just put that back in here, and now you're done. Okay, so here is the final answer for the function. F of x is equal to -3x times x plus 1 times x minus 2. Final answer. Okay. Sorry if my hand's shaking. I'm raising it up. If I put it down like this, then it's harder to focus, as I think I've said to you guys before. But here we go. Okay, so this is the one and only cubic function. It's cubic because it's third degree, right? If you multiply all this junk out, you would have -3x cubed, right? Plus blah, 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 blah. Okay. So we're finished, but I'll dig a little deeper. When you plug in -1 or 0 or 2, you get 0. When you plug in -1, it'll be -1 here makes the whole thing 0, right? If you plug in 0 here, that makes the whole thing 0. And if you plug in 2 here, that makes the whole thing 0. And let's see, when you plug in 1, you're supposed to get 6. Where'd it go? Here, right? Plug in 1 here, 1 here, 1 here, multiply it out, you'll get 6. Okay. All right, then 15, please. Some word problems at the end. Okay, 15. The relationship between Fahrenheit and Celsius is given by the formula F equals 9/5 C plus 32. Okay, so convert from Celsius to Fahrenheit or vice versa. That looks like y equals mx plus b. Sketch a graph of this function. Okay. Well, let's see. That looks like y equals mx plus b. Which one should be like x and which one should be like y? That looks like y. That looks like x. So this should be horizontal and this should be vertical, right? So f equals 9/5 c plus 32. That's like y. That's like x. Okay. Now just a very rough sketch. What do you get when you plug in 0? Well, 32. So I said this is 0, 32. And which incidentally means 0 degrees Celsius is 32 degrees Fahrenheit. Okay, some of you know that's the freezing point of water. Water freezes at 32 degrees F or 0 degrees C. And then I just graphed one more point. I picked C is equal to 5. Why 5? So I can cancel this 5, right? I'm plugging 4, but that's not as convenient. So if I plug in 5, that cancels out. 9 plus 32 is 41. So this is 5, 41. I'll raise it up there. And then there's a rough sketch. Right, and then what do they say furthermore? What is the slope of the graph and what does it represent? What is the f-intercept and what does it represent? Okay, f-intercept, take a look over here. I'll just use my finger there. That's like y. It's like saying what is the y-intercept? So the y-intercept here is 0, 32. What does it represent? When C is 0 degrees, F is 32 degrees. Okay, and what about the slope? We know the slope is 9/5, okay, which means when the Celsius moves or goes up by 5, Fahrenheit goes up by 9. Okay, so when C goes up by 5, F goes up by 9. It's almost double. Okay, so for me, if I want a quick approximation, I would double it. Okay, that means when centigrade or Celsius moves up by 1, Fahrenheit goes up by 2, roughly. It's actually 9/5 or 1.8. Okay, so that's the way that works. I think I said it, but I go ahead and write it here. I'm not going to spend time on it. But in case you didn't catch it, here were the answers to 2. Again, exponential, power, polynomial, fifth degree, trig, rational, algebraic. And those were the answers to 4. So A was capital G, B was little f, C was capital F, and D was little g. Okay, I will talk a little bit about 17 and then I'm done. I would have done everything I wanted to do for 1.2. Okay, and I was supposed to spend 1.2 Monday too, so I'm good. I might say some introductory remarks about 1.3 and then give you the quiz. Okay. All right, so I will set you up for 17, but not do the whole thing. Okay, 17, biologists have noticed that the chirping rate of crickets of a certain species is related to temperature, and the relationship appears to be very nearly linear. A cricket produces 113 chirps per minute at 70 degrees F, and 173 chirps per minute at 80 degrees F. Find a linear equation that models the temperature T as a function of the number of chirps per minute N. What is the slope of the graph? What does it represent? If crickets are chirping at 150 chirps per minute, estimate the temperature. Okay, I'm going to put the book down because it's heavy. But the basic idea is the hotter it gets, the more the bird's going to chirp. Okay, so I guess, if it's cold, the bird goes chirp, 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 chirp. Then if it gets hotter, it goes chirp, 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 I guess. That's the idea. Obviously, I don't make a very good bird, but that's what's happening. Okay, so here's what you do. They say T is equal to F of N. Temperature is a function of the number of chirps per minute. Okay. That's like Y, that's like X. Okay. So I write these as ordered pairs. Okay. So they told me, let's see, 113 chirps a minute, 70 degrees, 173 chirps a minute, 80 degrees. As ordered pairs, 113, 70, 173, 80. NT, that's like X and Y, right? That's like X, that's like Y. Okay. So now the problem just reduces to find the equation or the line that goes through these 2 points, right? And we've done that before. So first I'll find the slope, y2 minus y1, x2 minus x1. So 80 minus 70 divided by 173 minus 113. That's 10/60, which is 1/6. So the slope is 1/6. And then after that, use the point slope form. Y minus y1 equals m times x minus x1. And I'll let you take the rest of it from there. Okay, so I'm just going to say et cetera. Okay, now you don't get to say et cetera on any quizzes or tests. I'm the only one who gets to say et cetera, obviously. Sorry. Meaning I'm not going to go any farther. I think I've given you enough to finish the rest of the problem. Right? So put 1/6 right here. Here's your x1, y1. Plug it in, get the equation. And then instead of using y and x, switch it back to n and t, realizing this is x and that's y, and you take the rest of the problem from there. Okay? So that's the way that's going to work. Right, so I'm finished with what I was going to do for this section. I will talk very quickly about 1.3. What time is it? 9:30 something? Okay, so where are we headed for 1.3? New functions from old functions. So we're reviewing this. Okay, again, all of chapter 1 is pre-calculus. We're not doing any calculus yet. We're just reviewing pre-calc. Okay, because it's been a long time since some of us have done pre-calc. In fact, some of you didn't even have pre-calc last semester, so maybe a year or longer since you've had pre-calc. Okay, so I'll show you this, 37. Vertical and horizontal shifts. Remember that concept? Okay. Y equals f of x plus c, c units up. F of x minus c, c units down. F parentheses x minus c, c units to the right. F parentheses x plus c, c units to the left. If you want to put this on your formula sheet, you may, but again, the more you put on your cheat sheet, the less you have for other stuff, since you only get one 8.5 by 11 paper for the whole test. Okay, and here are some pictures of it. Here's a perfect example, I guess. Yeah, I don't have any hands to show you, but see that one in the middle, the black one, I guess, y equals f of x. So to the right of it, you see y equals f of x minus c. To the left, f parentheses x plus c. And then the one above in red, f of x plus c, but the plus c is not inside the parentheses. And then the bottom one, f of x minus c. Okay, I'm on page 37. A little bit harder. Okay, this one, stretching and reflecting. Okay, see y equals f of x, the black one on the right side. I can't point it out to you because I'm holding the book up. Okay, on the left side, you see f parentheses negative x. Okay, if you replace x by negative x, you get the reflection across the y-axis, you might recall. You see a stretch, okay, this one, y equals c f of x, where c is greater than 1. So let's say 2 f of x, you get that red one. This one might be half of f of x, half f of x. By the way, you did a lot of this in trig, right? Remember you start off with sine x, then 2 sine x, then it goes higher, right? Half sine x, it goes down. Okay, then way down to the bottom, negative f of x. Negative f of x is the reflection of f of x across the x-axis, as you can see there. Okay, so here are rules for vertical and horizontal stretching and reflecting. Okay, I do want to quit real quickly. I'll just show it to you. I'll probably go more over it on Monday, but it's basically all there. C f of x, 1 over c f of x. That's like 2 sine x, half sine x. Okay. The third and the fourth one down, and I don't know why it's yellow now, but anyway, f of cx, f of x over c. From trig, that's like sine 2x or sine half x. That changed the period, you might recall. Okay. So that either shrunk it or stretched it out. And then the last two, y equals negative f of x, reflect about the x-axis. F of negative x, reflect about the y-axis. Okay, and I'm going to put the book down because it's very heavy. Page 38, some examples. I'm going to show you something here. Okay, so the red one is cosine x. Remember from trig, cosine 2x, above it, amplitude is 2. Cosine half x, it kind of goes below, amplitude is a half. Over here, we changed the period, right? Oh, there goes the yellow. So you see the red one, y equals cosine 2x. Cosine 2x, the period is only pi. The regular cosine function has a period of 2 pi. Cosine 2x period is pi. Cosine half x, it takes longer to complete one period. That would actually be a period of 4 pi in that particular case. Okay, so I'm going to put this book down because it's too heavy. All right, I'm actually done, folks. Let me check the chat, and then I'll get you set up for the quiz in just a moment. Okay, so check the chat. Okay. All right. Yeah, about the tangent, it's very easy to forget that. Yeah, so you might have to review your text on the tangent function, or you can send me an email about that or come during office hours, but basically that's that. I do somebody just joined, so I got that. That's okay too. All right, that's fine. Okay, any other quick questions here? Otherwise, I'll go straight to the quiz. Okay, everybody get your cell phones out and get ready to take a picture. Okay. All right, and let me go ahead. Okay, in the chat. Okay, there's my email address that you're going to email me by 10:05ish. Okay, so here we go. So take a picture or a screenshot. Give the domain of the function. Number 1 is f of x equals x minus 5 over x squared minus 11x plus 30. A hint is you cannot divide by 0, right? And if you're not sure what to do, ask your mates, your breakout room mates, or look at a problem that I did just like that. Number 2, square root of 3x minus 10. So you should know something about square root, right? There's limitations on the square root function. Okay, I'm going to hold this up for a few more seconds, then I'll make it disappear, then I'll set up your breakout rooms. Remember, please put your first and last name, all your teammates' first and last name, not just the first name, make it easier for me. And your object is to get the answers right and get all of your teammates to get it right, because I will grade only one of them. And the only way you can be sure to get it right is if everybody gets it right. Okay, I'll hold it for a little bit longer. So go ahead and get started. It'll take me maybe 15 seconds to set up your breakout rooms, and then I'll have you go over there. If you finish early, you may leave. Email me at homm@hsmcctd.edu. Okay, I'm going to assume everybody has it, or if not, you can ask your teammates there also. So get started in it. I'm going to stop the share. I'm going to stop recording also.